Video Lecture 1, the Periodic Table. Up until the 1700s, scientists had only identified about 30 elements. These included metals like copper, silver, and gold. Gold had been known since prehistoric times. And nonmetals such as hydrogen, oxygen, nitrogen, and carbon. In the 1800s, scientists began to work with atomic spectroscopy, and they were able to use it to identify elements by their new line spectrum. In less than 100 years, scientists doubled the number of known elements. As the number of elements increased, scientists continually discovered new ways to classify and organize these elements. One of the first ways was the classification into triads. Here, elements were classified into sets of 3. They were classified by similar chemical properties, like atomic mass and density, things that were easy to measure. The middle element was an average of the first and last. So we see examples like calcium, beryllium, and strontium being, barium was the average of calcium and strontium. And chlorine, iodine, and bromine, iodine was the average, fell in between the chlorine and the bromine. Newlands in 1864 arranged the elements that were known at the time in order of increasing atomic mass. When he started to put these elements in order of increasing atomic mass, he noticed that the properties of the 8th element were like that of the first element. This helped him develop the law of octaves, which says that there's a repeating pattern of 8 elements. This highlighted the concept of the periodic table. The father of the periodic table is Dmitry Mendeleev, a Russian scientist. Mendeleev arranged the elements in terms of their atomic weights and grouped elements according to common properties. Elements that were in the same group had similar properties. Now, Mendeleev took the order that Newlands had set up and changed it up a little bit. He suggested that the atomic mass of some elements needed to be recalculated. He also skipped spaces to allow to keep elements with similar properties in line, and was able to predict new elements and their properties would be able to be filled into those empty spaces. So when we look at Mendeleev's periodic table, these spaces were elements that had not yet been discovered. And Mendeleev allowed those spaces to exist because as new elements were discovered, they would be able to be plugged into those open spots. Mendeleev stated that the properties of elements were periodic functions of their atomic weight. However, there were some problems that existed, especially within a few elements. When we looked at cobalt and nickel, or tellurium and iodine, or potassium and argon, after argon was discovered. This led to the work of Henry Moseley in 1914. Moseley was the first person to arrange elements according to the increasing atomic number. When Moseley rearranged Mendeleev's table, the problems disappeared. Arranging elements in order of increasing atomic number took care of some of those problems. And what we saw is that when we increase the atomic number, physical and chemical properties show a repeating pattern. Here was Moseley's periodic table. It looks very similar to ours. Notice again, we still have some open spaces. Glenn Seaborg is credited with working our modern periodic table in 1945. He discovered many new elements. If you've noticed, element 106 is actually named for him. Seaborg rearranged the periodic table by taking thorium, proactinium, and uranium out of the main body of the table and started a new series of elements. This series of elements was developed by Seaborg. The, the periodic table would have been too long if the rare earth metals were included in the arrangement by increasing atomic number. As you can see, this is what the periodic table would look like. Our periodic table takes these two blocks, if you remember these are the F blocks, out of this section of the periodic table and put our F blocks underneath, which is why we see the periodic table go from 55, 56, 57, and that big jump all the way to 72, 87, 88, 89, and then the jump to 104.